Today we're going to talk about rate of change and slope. This is TEKS from Algebra 1, A.3A, and A.3B. So first we're going to talk about our brain dump. What are things we've learned so far? So this unit, this is a part of the formula chart that we're using. Some of the big things to discuss today is the y-intercept is where it crosses the y-axis. This right here, the reason we say rocks is because this is your root, this is your zero, but it's also your x-intercept or solution. So again, there's your slope, that's your rise over your run. This is your y-intercept. Another word for slope is rate of change. A lot of times those real world problems will have rate of change. Memorize this triangle. We have a positive slope. If you were to write your name, you write it going up. If you were to write your name, it's going down. That's negative slope. A horizontal line is a zero slope, and a vertical line is an undefined slope. Write these down if you haven't yet. It'll help you with this section. Okay, so we're going to find the slope between 2 points. First thing we want to do is we're going to label our points, x1, y1, x2, y2. Pay very close attention how we're going to plug this into our equation. We're going to do on the numerator y2 minus y1, and on the denominator x2 minus x1. After you plug in these values, next we are going to simplify. When we simplify this, we get the answer of 1 over 13. So our slope is equal to 1 over 13. Now go ahead and pause this video and go ahead and practice this one now on your own. Now you can check how you did. So I plugged those values in here just like we did on the previous problem. We have y2 minus y1. Notice here I had a double negative, so it ended up becoming a positive. That's how I got a 28 over negative 14, which reduces to negative 2. Okay, we're going to do the same thing again, but now we're looking at a table. So you actually get to pick any 2 points from this table. I'm going to be real honest. I like to pick positive numbers and zeros if I can. So I'm going to pick those values, and I'm still going to label them x1 and y1, x2 and y2. It is still our change of y. So on the top, I have 3 minus 12, and on the denominator, I have 0 minus negative 2. So look where those numbers came from. I now have negative 9 over 2, which I can leave like that. If I reduce it, I do get a negative 4.5. So my rate of change of y with respect to x, my rate of change is negative 9 over 2. Now with these real world problems, I still want to do my x's and my y's. Now this graph was turned horizontally, but doesn't change anything. I'm going to name my top row x's and my bottom row y's. So go ahead and label those and set up my equation. Okay, my equation set up, and when I simplify it, I have 7 over 1. Now this is a real world problem, so we can say that my rate of change is equal to 7, but I want to know 7 what? So in words, I'm going to put my y per x. So $7 per 1 week or per week. So again, it's always going to be the y per x. Okay. Let's look at this graph here. Same thing again though, whenever we're doing slope or rate of change, we're still going to do this y value here, okay, over your x values. Now we can do rise over run, or we can find points and do the slope formula. It is a personal choice. All you need to do is find pretty points on your graph. What I mean by pretty points are points that go through the corner. So on this one, if I were to try rise over run, pay very close attention. Biggest mistake is people saying I'm up 1 over 1, up 1 over 1, up 1 over 1. But you got to pay close attention to the spacing. These are spaced by half. So this is actually only going over half, 0.5. And this is going up by 200. So if I'm going up 200 and over by 0.5, that means that my rate of change is equal to 400. 400 what? 400 feet squared painted over a gallon of paint. So if you're looking for a complete sentence, that's what you do, okay? Last problem, okay? Go ahead and pause this video and try this one on your own. Pay attention to y per x. Okay, check how you did here. So again, you can do rise over run, or you can go back to our slope equation. Right here, be careful, I started at 50 and I went up to 150. So I went up 100 over 1, up $100 over 1. So that means it was $100 per deposit. Hopefully this review helped you practice finding the slope and the rate of change.